Hi Lindsay's class, it's John here and I'm on Hornby Island off the west coast of Canada, and it's snowing today, which is pretty amazing. And so you can see in the background here I'm on a beach covered with logs, but the logs are covered with snow. And so I'll just give you a bit of a view around. There we go. I've never seen it snow in here before, but that's what's happening today. So it's really pretty. And we'll talk about rocks in a minute. Hello Nora, Fayez, Tara, Bedra, Liwa, Ali, Talal, Lara H, Lara F, Faisal B, Faisal F, Aziz Q, Aziz M, Kata, Fadia, Layana, Awa, Zaid, Munib, Ryan, Summer and Jassem. I'm John Cox. I'm a geologist, and I'm also Lindsay's dad. And I'm sat here on Hornby Island on the west coast of Canada. And I've got some questions here that you've sent me, and I'm going to do my best as a geologist to answer those questions. And they're really good questions that are very special towards geology, because most other subjects don't have these sort of questions. So the first one was, how heavy is the Earth? And how do we know? That's a really good question. We think the Earth is 6 times 10 to the 24 kilograms in terms of its mass. That's a pretty big amount, isn't it? Another way of looking at that is that it's 6 trillion kilograms. Now, how do you figure that out, right? You can't just put the Earth on some weighing scales, can you? And so we've got a couple of ways of doing it. The first way is a fairly rough estimate, where if you got on an aeroplane in Kuwait and flew all the way around the Earth, and you kept going west and further west and keep going round and round, in the end you'd come back to Kuwait, and you would have, in fact, that distance you've travelled would be the circumference of the Earth. And that distance is about 40,000 kilometres. And by a simple mathematical formula, you can work out from the circumference of the Earth that the radius of the Earth is about 6,400 kilometres. And then from another mathematical formula, if you know the radius of the Earth, because the Earth is approximately a sphere, then you can work out the volume of the Earth. And then, once you have the volume, the density of the Earth is the mass divided by the volume. And we can work out the density of the rocks on the surface, which give us an estimate of the density of the Earth. And so then, if you take the mass over the volume, that gives you the density. And so by doing that, you can work out the mass, which comes to 6 trillion kilograms. Now, there is a more accurate way of figuring it out, which is using a physics formula based on the gravitational attraction between two objects, and doing some fairly simple experiments using a 1 kilogram weight on the Earth's surface and seeing how rapidly it falls. Then you can also come up with a measure which of the mass of the Earth, which is probably a little bit more accurate than the first one. So that's the first question. Oh look, the diving are... Penny, don't go any near the edge. That's the first question. And then second question was, how do we know what's inside the Earth if we can't go down there? And that's another excellent question. There have been wells drilled as deep as about 12 kilometres on the Earth's surface. So that's not very far down, really, when you think it's about 6,400 kilometres down to the centre of the Earth. But we have drilled down, and so when we drill those wells, we can bring the little bits of rock back up to the surface. So we have seen some of those rocks that are 12 kilometres deep. We also get information from volcanoes, because volcanoes, the lava that comes out of volcanoes originates deep within the Earth, and that tells us something about the temperatures and the materials that are down there in the Earth. If we want to go deeper, then seismic waves are a type of shock wave, And seismic is used for exploring for oil and gas in Kuwait, but it's also used for examining the internal layers of the Earth. And little shock waves are set off on the Earth's surface, and those shock waves go down and travel deep into the Earth, and they bounce back off the different layers, such as the mantle and the core, and so they give us information about the materials down there. We get more information from the Earth's magnetic. I'm back up at the house now, because it was a bit wet and snowy down on the beach, and here's the house in the background, and it's covered in snow, as you can see, and it's just a beautiful morning here. So now I'm going to have a look at your questions and try and answer some of the geology that you've asked me. And I'm just going to sit on the ground here to get comfy, and I'd like to say hi to all of you, to Nora and Fayez and Tara and Bedra and Liwa and Ali and Talal and Lara H and Lara F and Faisal B and Faisal F and Aziz Q and Aziz M and Kata and Fadia and Leanna and Awa and Zaid and Munib and Ryan and Summer and Jassem. And hope you're all doing really well today. Your last question, how do geologists know the age of the Earth? That's because some minerals, I think you've heard of feldspar, they contain very small amounts of radioactive materials, and these radioactive materials very slowly change or decay over time. So we have the original parent isotope, and that decays to a daughter isotope, which is a different element. And we have very, very sensitive machines called mass spectrometers, which can measure the amount of parent and the amount of daughter isotopes. Doing some mathematical calculations, we can figure out when that mineral actually formed. And the oldest rocks have been found in northern Quebec, are at about 4.3 billion years old. And the meteorites, which we think formed at the start of the solar system, are as old as 4.5 billion years. So that's how we know. Bye for now.
Yes. Hi. Well.
Wave to your sisters there, Benny.
Hi. Is this a video?
Yeah.
What?
Benny in a tree, look.
Ah!
Wave, and a wave. Always climbing up.
Wait a minute. You're gonna freak out once I do this. But no. Okay. Here it goes. Woohoo!
Wave.